All right, so good morning everyone. My name is Paradies. I'm working for SAP as a software developer in the HANA department. And on behalf of the SMB task force, I'm going to present the current status and progress on the BI workload. And basically, I will just extend on the talk that Arnaud already gave yesterday. So here you can see the task force members, which are basically the same as for the interactive workload. And then on the next slide, we will also see why this is actually a good idea. So just a quick recap for the interactive workload. So yesterday we saw that the interactive workload mainly consists of these 14 complex read queries, and also in conjunction to that some simple read queries and also updates. And usually they can be characterized by they start at a single vertex, which is usually a person, and then kind of explore the proximity within 2 or 3 hops of the graph. And in total, they usually just touch a comparably small part of the entire graph. So for relational guys, this could be seen as some sort of OLTP style workload. And in contrast to that, we also have the business intelligence workload, which focuses more on analytic queries that are aiming at grouping and aggregating over the entire data graph, and are usually way more heavy in terms of the data they read and access. And usually they are more characterized by long periods of reads, interfered by certain batch updates. Currently, as I said, in contrast to the interactive workload, where we have these 14 plus 7 read queries, we have 24 queries in the BI workload. I'm going to show just 2 of them on the next couple of slides to give you a first glimpse of how they're going to look like. And interestingly, which is also the reason why we share basically the workloads in the task force, is that we use the same data generator for the BI and for the interactive workload, and also the same benchmark driver. So everything that Arnaud and Peter also talked about yesterday about the data schema also similarly applies to the BI workload, just the type of workload and the queries we run are different. All right, so I just picked randomly just 2 different queries. So one is something very relationally. It's the query 1, and basically it says, given a date as input parameter, find me all the messages before that date, and then perform a grouping first by the year, and then just group in the second level by the type of the message. So just grouping by post or comment. And then on the third level, just grouping by the length of the message. And then what we return is basically for this 3-level grouping, the year, the message type, the length, and basically here we have these 4 different types for the length of the messages, and then also basically 3 results from aggregations. So we have a simple count, we have an average and a sum, and then also here basically a fraction of that. Just for the sake of brevity, I just omitted here the sorting and also the top k. So usually we limit the number of results to 100. So far you might think, okay, this actually looks very relational and not graphy at all, which is why I just chosen another example that is more graphy. And here basically the input parameters are a person, a country, and a tag class. And then it starts by giving a person, find all the other persons that are living in the country with a given name and are connected to the given person by a path through the nose relation. And that's already kind of a transitive computation. And in this case, this is really the graphy part of this particular query. And so in the entire workload of the 24 queries, we have a couple of them that are more graphy and others that are more relational-like. And then, so for this example query, basically the output is that we return for each group, where basically the grouping criterion is first we group by the tag name, where the tag name can be a child of the given tag class, and then second by the person ID, and then we just aggregate over the number of elements in each group. So this is currently the list with the head titles of all 24 queries. I just don't want you to read all of them. I just wanted to give you a broad picture. And from some of the queries, it's already quite obvious that these are not some sort of artificial queries, but you could even just from reading the title already see some real use cases, such as here, for example, trending posts, or also the tag evolution in query 3. And then here, more towards the end, you can also see that we were actually quite creative in coming up with these titles, such as in query 19 or query 21. And yeah. So that's it so far for just giving you a broad overview of the BI workload. Currently online you will not find officially yet in the documentation the specification for these queries, and I will be just talking about the current status in the following slide. But before that, just another excursus. I think during the last couple of weeks we spent a considerable amount of time on the choke point identification, and I think yesterday Peter already introduced them quite briefly. So choke points are basically implementation challenges that we want to trigger with the workloads, and we already have a set of choke points defined for the interactive workload, and they are coming mainly from relational systems, but we also have some graph-specific choke points that are going towards the direction of transitivity computation. And for the BI workload, we further extended that by also looking at choke points that are coming more from the relational world, in particular here from the TPCH world. And here I just pasted an example of how these choke points are going to look like. So here you can already see that those are more BI heavy, so with the focus on aggregation performance here. And currently we are in the process of defining for each of the queries that we already have specified which choke points actually apply in order to have a better understanding total that we cover all the choke points that we have identified. And yeah. All right, so current status is we defined all 24 queries in plain English text, and we are currently kind of reworking them a little bit because as it's just plain English text, there's always at least some way of interpreting the specification in different ways. So we are currently polishing that up. For the benchmark driver is already able to read the generated parameters from the data gen. And something that has to be done in the future is the query mix. So what we already have for the interactive workload, that we specify the fractions of the specific queries, how often they occur in the final workload in the benchmark. So this is something that we have to tackle. For the validation phase, we have currently 3 different implementations from Sparsity, Neo4j, and Postgres. And there we have successfully validated 22 out of 24 queries. And for the remaining 2, we are still in discussions about the semantics of the remaining 2 queries. And for the choke point analysis, we already completed 8 out of 24 queries, and we are going to proceed for that within the next couple of weeks. If you want to have a sneak preview of how the Postgres draft reference implementation could look like, you can just check it out here. If you like to read nasty SQL statements, I encourage you to have a look at it. Yeah, to summarize, basically the next steps that we have to do and take is basically to finish up the choke point identification to see whether we already covered all the choke points that we defined for the 24 queries, and also to finish the validation of the remaining 2 queries. And what is currently missing is are basically updates. So currently this is just read-only, but we are now in the process of also adding these batch updates. and basically we then also will have to extend the benchmark driver, because the way how the updates are then triggered is a bit different from the interactive workload. And finally, we also have to do some more polishing on the query specifications. That's all that I have to, wanted to say about the BI workload. Are there any questions?
Could you elaborate on the batch updates? Is this an insert-only update, or do you delete objects? Do you modify objects?
As I said, it's currently totally open. I think it's likely that we will follow a similar approach than TPCDS.
So in the previous talk, someone said that we validate the results of the query, right? And so how do you validate if you don't have I mean, like even if you have the read committed, it depends on when things were committed. Do the queries in the face of updates, how do you know, I guess, what the right answer is? How do you validate that?
Maybe Alex?
That's a big problem. It's a work in progress. It's actually a very hard to do in a parallel fashion.
So the queries can be executed in parallel, but one after the other. A single query can be parallelized, but one after the other. There needs to be sequential.
Right. Like, so the short answer is during validation, it's single thread. However, all of the queries, like having a scheduled start time, still here, and to get a total ordering of the query. So all of the queries that have a dependency between each other are executed in the same order, whether it's a single threaded or a parallel.
But so how do you define dependencies between two, like a write and a read, if you're allowing, again, not like read committed, then how do you? That's a hard problem, but I mean, then you guys need to discuss this, because.
No, but this is already discussed. So this is kind of solved by this is not a trivial thing indeed, but the driver goes to, actually with the help of the data generator itself, goes to quite a few lengths to ensure this.
Okay.
So there is this time window that when things happen in parallel, in principle, of course, you do not control when a query starts, but there is a guarantee that beyond this particular window, everything has already been processed.
Okay,
That's something that the driver maintains,
Okay.
and we know, and therefore the updates and the queries are generated in such a way that the dependencies are more than this window away.
Okay, got it. So basically, you always validate against worst case time, potential worst case, like, given your constraints, which was 1 second post schedule time, you validate after that. Okay,
Yeah, and then no matter how you execute it, you should see the same result.
Okay. That makes sense.
Okay. Any other question? So thank you very much.